Hello everyone. Today I'm going to talk about a HOTS question, also known as KBAT, in Chapter 5 of SPM Form 4 Mathematics. The chapter is called the Network in Graph Theory, and this is a totally new chapter in the new KSSM syllabus. I realized that there isn't much reference available to the students yet at this moment, so I've decided to record this video because I've not seen any video teaching about this method in solving this kind of question. Okay, so here's the question. Determine if the graph can be drawn with the given degrees of vertices. Draw the graph if possible. Right, so we are given with a set of numbers. So 1, 1, 2, 2, 3, and 5. Okay, so this question is actually quite similar to the textbook in page 134, question 5 and 6. Okay. So if basically for this kind of question, if you do not know any methods of drawing it, you need to keep trying to draw many different kinds of graph until you find a suitable graph that fits to the condition or the criteria given by the question. So today I'm going to teach you a very useful method that can help you to draw different kinds of graph based on the different degrees of vertices. Okay, so let's start with the number of degree of vertices. Okay, so we have 1, 1, 2, 2, 3, and 5. So each of the number here represents a degree for one vertex, for each vertex. So we can actually tell how many vertices we have here. So the number of vertices is actually equals to the number of the total number we have here. So 1, 2, 3, 4, 5, 6. We actually have 6 vertices here. And then the next thing we have to determine if the graph can be drawn or not. So we have to remember the formula that the sum of the degree of each vertex is actually equals to 2 times of the number of edges. So if we sum up all the numbers here, we must get an even number because we have a 2 here. So we just find the degree of vertices, which is the sum of the degree of vertices, which is 1 plus 1 plus 2 plus 2 plus 3 plus 5. So 1 plus 1 plus 2 plus 2 plus 3 plus 5. So we get 14. Okay, which is an even number. Therefore, we say that the graph can be drawn. So the next thing is we have to draw out the graph, right? So how do we draw out the graph? So let's define a set D that includes all the degrees of vertices 1, 1, 2, 2, 3, and 5. Right? And then we can actually label it. Let's say I label it A, B, C, D, E, F. Meaning that the degree of vertex A is actually equals to 1, degree of vertex B is actually equals to 1, degree of vertex C is equals to 2, and so on. Okay, the next thing is we will need to delete one of the vertex. So let's say I delete the vertex F. So vertex F is the degree of vertex F is actually 5. So when we delete this vertex F, we have to take out all the corresponding edges connecting to F. So if we have 5 here, we are actually deleting 5 edges. So the 5 edges is actually connecting to the other vertices. So let's put it in a graphical view so that you can understand it better. So let's say I have a graph of this. And I say P, Q, R, S, T. And then we state the degree of each vertex. So degree of P is actually equals to 2 because there are 2 edges connecting to it. Degree of Q is actually equals to 3. R, 1, 2, 3 also equals to 3. S is 2. And degree of T is actually 1, 2, 3, 4. So for example, if I want to delete the vertex T, okay, so all the corresponding edges have to be deleted as well. So I have to take out all this. And then when we take out all of the edges here, we have to minus out 1 from the other vertices. Right? So once we take out the t, what do we left with? The graph will turn into this graph. Right? Then we calculate the degree of p again. So now p equals to 1, q equals to 2, r equals to 2, s equals to 1. Degree of the degrees are, the new degrees are here. So actually we are when we take out the degree of t, when we take out the vertex t, we have to minus out all the corresponding edges. So 2 minus 1 we get 1, 3 minus 1 we get 2, 3 minus 1 we get 2, 2 minus 1 we get 1. Alright, so this is a graphical explanation for it. So here, if we take out the vertex f, right, we have to minus up 5, which is from 1, 2, 3, 4, 5 from the other vertices. Alright, so we say d prime is a set of the remaining vertices without the f. So if we take out the 5, we have to minus out 5 from the other vertices. So 1 minus 1 is 0, 1 minus 1 is 0, 2 minus 1 is 1, 2 minus 1 is 1, 3 minus 1 is 2, and we do not have to write the f anymore because we have already deleted it. Right? Then we can repeat the process again. So now we take out the degree of 2, which is the vertex E. When we take out the vertex E, we have to minus 2 edges. So the 2 edges actually is connecting to the C and D, right? So we take out 2 means that we have to minus out 1 from C and 1 from D. So it becomes 0 and 0. And we don't have to write the vertex E anymore because we have already taken out this. Alright, so now we are left with 4 isolated vertex. Okay, so we can actually draw it pretty simple. We just draw 4 dots, and that is our A, B, C, and D. Right, isolated. All of the degree of vertex is actually 0. There are no edges connecting to each other. Alright, then we reverse the process. Alright, so we have already taken out E. Now we have to add it back. When we add the E back, we are actually connecting the E with C and D, right? So we have to add, in the graph here, we have to add our E that is connecting to C and D. Alright, so the degree of E is actually 2, 1, 2. Degree of C is 1, degree of D is 1. So we are now at here, which is correct. And then again, we have to repeat the process by adding back the vertex F. Okay, so let's say I add a vertex F here, and the vertex F is connecting to each of the other vertices because this is 5. So we are having a 6 vertices, right? So when we add back the F, which is the number 6 vertices, then we have the number 6 vertex, then we have to add back the edges corresponding to it. So in the previous steps, we are actually deducting from every single vertex of the remaining vertex A, B, C, D, E. Now we add back the F, so we have to connect it back. So we have to add back to A, to B, to C, to D, and to E. So we add back all the corresponding edges. Alright, so we are actually done with our graph, but to check our steps, so we can calculate the degree of A is actually 1, right? So we are having 1 edge connecting to A. So degree of A is 1. Degree of B is also 1, which is true because we are only having 1 edge connecting to it. Degree of C is 2. Degree of C, 1, 2. True. Degree of D is 2 as well. 1 and 2. That's right. Degree of E is 3. 1, 2, 3. Degree of E is 3. Degree of F is 5. 1, 2, 3, 4, 5. So the graph has satisfied all the degree of vertices from the question. Right? If we redraw the graph without the labels, okay, we can actually draw a different shape of the graph. So let's say I can draw something like this. Okay, so both of these graphs are actually the same because the degree are still the same. This is 1, 1, 2, 2, 3, and 5. Okay, so 1, 1, 2, 2, 3, and 5. So that's all. We have completed our graph. I hope you learned something new from this video. Thank you for watching. If you like this video, please give a like. And if you find this video helpful, remember to share it with your friends so that everyone can master this technique. Remember to subscribe to my channel for more exciting videos. See you.